radicals. I think this is all we'll do today. We'll finish this one up and move on. Let's do a rationalizing one. Is there a rationalizing one on there, sir? Oh, okay, so rationalizing. Here we go. This is where we first learned about the conjugate, like we used in that identity stuff. So we're not allowed, well, we are allowed, but it's not proper maybe, to have radicals in the denominator of a expression. So, quick example. If we end up with 2 over the square root of x, and I tell you to rationalize that, what are you going to do to both top and the bottom? Times by root x. That's rationalizing, right? Okay? Because when we multiply this fraction, we go straight across and we get square root of x times square root of x is the square root of x squared. Well, square root of x squared is just x. It gets rid of the square root. So this answer ends up looking like this. And we're done. So that's rationalizing a monomial. Real quick. Okay? Now when we do a binomial, that's where we have to try and figure out, where we kind of pull in our knowledge, if you want to call it knowledge, of multiplying binomials. Because let's go 2 plus, whoops, not 2x, 2 plus y, and we'll divide that by square root y minus 3, just to see what happens. Now, we're still not allowed a radical in the bottom, like that. We're still not allowed a square root in the bottom. So to rationalize a binomial, I have to multiply it by that conjugate thing. Same thing we did with those identities. So what's the conjugate here? Yeah, root y plus 3. So plus 3. And root y plus 3 again. That all fit? Yeah. But now we got a FOILer. We got to distribute everything. So as I go here, I'm going to get 2 root y plus 6 plus y root y. That's a whole new ball of wax. Plus 3y. So nothing we can really simplify up top either. We don't care to, because we're allowed radicals up top. But in the bottom, what ends up happening, if we just look at it before we do it so we don't have to write it down, we get 3 root y's and then minus 3 root y's, don't we? What happens to those? They're canceled, and that's what we want. So we just end up with square root of y times square root of y is just y. And then negative 3 times positive 3 is negative 9. So we've rationalized it. We've gotten rid of the radical in the bottom, square root in the bottom. And those are the two things you're expected to do. Maybe I'll quickly do one with yeah. That's it, right? That's right. We just stop there. But I'm going to do one with a cube just to show you the difference, right? Because what we're really trying to do, if you think back to grade 10 pre-calc, where we did the exponent and we tried to get rid of that and simplify it and make it 1. That's what we're doing here, right? Because square root of x is just x to the 1/2, and times x to the 1/2, well, that equals 1, right? So we're going to quickly do another example that I think it's maybe a little different, but we'll just go like this. Cube root of 2. Okay? So this is just to make you think a little bit differently about this. What's the exponent on that 2 then, if we were to change it to an exponent? 1/3, yeah, 1 over 3. So what do I have to add to 1 over 3 to make it equal to 1? 2/3. So that's what we use to rationalize. Whatever it would be to make it 1. So in this case here, I'll show you. 2 to the 1/3 is what's there. I have to multiply that by 2 to the something that I would add to the 1/3 to make 1. Because then it's 2 to 1. It's just 2. And that happens to be 2/3. So if you think back to grade 10 pre-calc and using that exponent rule where we, put the boots at the front door and the hat, hang the hat or something. Yeah, we don't worry, Sarah. We never ever talked about that. That's Crystal and them. That's Palm's class, wasn't it? Isn't that what she always used to say? Yeah, doesn't matter. So we got the cube root of 2 squared times cube root 2 squared. And we get our answer is x cube root, I guess we can say 4, whatever, over 2. That would be our answer. Gets rid of the radical in the bottom.